Hello, and welcome to this course, Introduction to Blockchain Cybersecurity. This course is a presentation of Coding Boot Camps. My name is Jim Sullivan. I am your instructor. Before we get into the cybersecurity, let's take a look at how blockchain works. Two prerequisite courses, Introduction to Blockchain Technology and Introduction to Cybersecurity. Both of these courses are offered by Coding Boot Camps. Please consult your learning materials. So a little bit about blockchain fundamentals. There are more than 1,500 blockchain projects currently in flight. These are major projects according to CoinCap Market. Services to several industries include mostly financial transactions, but transactions on other assets. Current net worth is about $259 billion. Blockchain solutions are about to grow by 75% through 2022. That's according to IDC. Worldwide annual revenue is about to be about 20 billion by 2025, and Bitcoin it's very volatile, but it's now worth near $120 billion. So a blockchain is a database. Certainly it's a repository of data. It's in the form of a ledger and has, well, let's just say now, two distinct properties. It's chronological and it's decentralized. So blockchain runs on a distributed network. Again, it's decentralized. It is immutable. Its public blockchains are anonymous. However, private blockchains can be named. It's fully traceable and can run applications called smart contracts. So the basic components of a blockchain are the node, or the host or computer on which the blockchain is running, the block itself, and the ledger. And this is a good picture right here because it shows these are individual nodes. We can see it's hosting, the nodes are hosting the blocks, and we can see here the blocks are generally the same. We can see block 22, block 23 exist on all of the nodes. The facts, however, are slightly different because each of these nodes are processing transactions that are coming in from users. So the individual miners that organize this network and run all these nodes are updating their nodes by processing transactions. So a user or computer with a blockchain for Bitcoin, we can see here, if we talk about nodes, nodes generally have the ledger. There is one ledger for Bitcoin. There is one ledger for Ethereum. And there's one ledger for other blockchains or distributed ledgers technology products as well. However, in Bitcoin, Ethereum, there is one copy of the ledger. The nodes can vary slightly. So we can have nodes that look more toward mining and specialize in that. We can have full nodes that have everything. They do mining. They have the full copies of the ledger, and light nodes that have a subset of what's on the full node. And this really is just to save resources. And we can see here the nodes are all connected on a fully distributed peer-to-peer network. So very, very difficult to attack the blockchain, because if any of these nodes come under attack, they can be taken offline. And then when the attack is stopped, they can be brought back online, and all of the data can be relayed back to that node to bring it fully back online. Blocks contain the actual data, so they contain the continuous transactions. So where one block stops, the next block begins. Blocks are sized just for organizational purposes and prevent runaway blocks. And as we can see here, there is a hashing function that's used to hash the data. Hashes are very sensitive to changes that actually change. So we can see the hash of this block is part of the data for the next block, and the hash of this block is part of the data for the next block. Right there, these are the blocks that contain data, and they are chained by hashes. So the internals of a block. So what's the structure? Well, we have a block size, and then we have header information, which contains timestamps, version informations, Merkle root trees we'll get into, the previous block hash, a transaction counter, and then the list of transactions. And the transactions really are, well, in the case of Bitcoin or Ethereum, the current asset, who owns it, and then who owns the next asset, so the transaction information for transferring that asset to another owner. So again, here we see the block structure. We have data and we have the hashing functions that link them together. And all of these blocks will exist on a node. So all of these blocks all exist on a node, and these nodes are replicated throughout the network. If we take a look at a ledger in Bitcoin or Ethereum is very similar to a financial or a bank ledger. It's stating the transactions and the current status of assets. So we can see here what the assets are and who owns them. And the ledgers here have the transaction data, and they are listing, again, how the transactions are proceeding. So somebody makes a transaction to purchase an item, and an amount of cryptocurrency goes from one ID to another ID, and that's exactly what is being tracked in these blocks. So quick actual demo. We can see here we've listed some details of a block here, or a ledger, and we can see here the details for this asset. We can see that there's been an update in some information. There are transaction IDs. TXID typically means transaction ID, and that's what it is in this case. We can see a name, and we can see this name has been updated. Some contact information has been updated. Some email has been updated. So these are attributes that go along with the ownership information for an asset. Now, obviously, this is not anonymous, because this is a screenshot from a private blockchain where the transactors want to know one another. If this was a public blockchain, we wouldn't see any of this. It would all be we would only see one ID, which is called a wallet ID. So let's have another look at the ledger in a simplified form. So a ledger, you could think of it as cells in a spreadsheet. We can see here the individual transactions are occurring. T1, T2 are all occurring here on the ledger. And then this one single, so this is what would exist on an individual node. Then we would have this same ledger replicated on many nodes, and then all of the individual nodes would have miners who actually organize and run the node, and they are all assisting in keeping the blockchain organized, and they are processing and clearing the transactions. So working with a blockchain, a transaction is generated, and there is a creation of a block, and what happens is the block has transactions written to it. Ultimately, we need to come to consensus, because these blocks and the ledger all have to be synchronized, so they all have to be the same. Once we determine which is the block which is going to be the block that has what we call the truth, or all the correct transactions, it's broadcasted and validated by the rest of the network, and then it is added to the full ledger. Well, consensus obviously has to be a big part of this process. And there are consensus algorithms in blockchains. One is called a proof of work, another is called a proof of stake. There are others as well that are being experimented with and being looked at. Currently, the most popular is proof of work and proof of stake. Proof of work is by far the most popular. However, it does consume a lot of resources. And the idea is that the miners, when they when they update and clear the incoming transactions, they run a very difficult mathematical puzzle to find the hash for that particular block. So it validates that the miners are actually doing the work on the block. It validates that they are contributing electricity and computing power to the Bitcoin network. Now, once a miner wins that proof of work, so if he or she is the first to solve that puzzle, the other nodes will validate that they indeed have the same transactions. They quickly vote, and then that new block is relayed to the rest of the blockchain network. And then the winning miner is paid a reward in, well, if it's Bitcoin, it's Bitcoin. If it's Ethereum, they're paid in Ethereum. So let's discuss smart contracts. So a smart contract it's a computer code. It's an application. It is usually run between two or more parties. It's used on a blockchain and consists of a set of rules which make up an agreement, very similar to a legal agreement. And how is it used? Well, the rules, it can be just as simple. If a certain condition is met, money is paid from one user to another. So the cryptocurrency goes from one wallet to another wallet. And that continues till the work is finished. So this we could see here, it's evaluating rules. It's going through some type of, this might be a escrow type of approach. So where one party sends their cryptocurrency to what they call an escrow, and then as certain conditions are met, those assets then are transferred to the other party. So in summary, the blockchain is a fully distributed set of nodes. It's a ledger. It's a ledger made up of small blocks, which can be compared to cells in a spreadsheet. There's, in the case of Bitcoin, in the case of Ethereum, there is one single copy of the ledger. Since we have many people working on it, it can drift a little bit, and we saw examples of that, how the data in there can drift. So we have to come up with a consensus to synchronize to make sure everybody has the same copy, and that occurs about every 15 minutes or so. Block times can vary slightly, and we validate those transactions in there, and then we move on to the next block. In the next lesson, we are going to have an introduction to Ethereum. And again, please consult your training materials for these courses, Hyperledger System Admin courses. Again, we can see here all system admin, Hyperledger Fabric for developers. Learn Solidity by example. So Solidity is a popular language for writing smart contracts. Introduction to Ethereum, Introduction to Development for Corda. And there are also private tutoring sessions available for blockchain. So again, please look into, if you're interested in any of these courses, again, please consult your training materials. And again, thank you for watching this lesson, and we'll see you in the next lesson.